Hi, my name is Alieanna. Today we are going to present for LAB3, which the title is Decoder and Encoder. For part 1 is decoder. Uh, the function of decoder is to change codes to signal, which is binary to decimal output. Binary input to decimal output. Okay. For part 1, there are 3 binary input, which is B, C, B, A, and 3 enable inputs, which is G1, G2A, G2B. And there will be 8 output, which is LED, which is Y7 to Y0. So this is the result that I get from doing the simulation in multisim. So I'm going to construct my multisim based on this input given. First of all, we need to set for the enable input, which is the pin 6 was in high active conditions, and for pin 4 and 5 was in low active conditions. Okay. The first one is C. This binary input for the first one to activate the output Y0 is 000. So we can see that the output of Y0 was in active conditions. Okay. Next one is the binary input was 001, and the output will be in active condition in Y1. Okay. Next one is 010, and the Y2 output will be in active conditions. Next is 011, and as we can see, the output of Y3 was in active conditions. Okay. Next one is 100, and the Y4 output was in active conditions. Next is 101, and we can see that the output for Y5 was in active conditions. Next is 110. The output for Y6 will be in active conditions. Next, and the last one is for Y7 output, which is the binary input was 111, and the output of Y7 will be in active conditions. In conclusion, and as we can see here, in this binary input there is XXX. It was stated XXX, and you can see the output was 1111. It was all in high conditions. This is because if the enable input was inactive, so any binary value was inserted in the input, which is CBA, there will be no output. There will be no output that we can select. So yeah, that's all for part 1.
Hi, my name is Loong, and I will explain the function of the encoder, and then I will do a simulation by using the encoder to further understand how does an encoder works. So what is an encoder? An encoder is a IC that can convert decimal input into binary output. So this is basically what the encoder will do. And then from here we can see this is the component, the diagram of the encoder. And from the simulation, we will be using the 74LS148 NAND encoder. And then we see the encoder, we can see there at the left side, there is D0 to D7. This is the decimal input of the encoder. And then from here we can see the A0 to A2. So this is the binary output, okay, of the encoder. And then we can see there's a EI here. This is the enable input. And we need to turn on this enable input in order to activate the encoder. Okay. As we also can see, there's something like a bubble here at the pin of the encoder. If this means that this is the active low. So when here is 0, that means here is activated. Okay, so we'll be doing a simulation with this encoder by referring the table, the truth table here in the Microsoft Word. And we can see for the A0 bar, there is X for every combination in A0 bar. That means it's a don't care situation. What does it mean? It means by that even if you turn on or turn off the A0 bar, it won't change your output. Okay. So first, we will be activating the A1 bar. Let's play the simulation. Okay, we activate the A1 bar from the decimal input, and then we can see the binary output. Okay, the Y0 probes light up. So according to the table, Y2 to Y0 is 0, 0, 2, 0, 0, 1. And then we can see the digital display are displaying the number 1 at the 7 segment digital display. So here is the 1. And then we proceed to activate the A2 of the decimal input, and then we can see the binary output is 0, 1, 0, and the digital number showing is 2. And then we move on, activate A3 bar, and we can see the output is 0, 1, 1, same as the table, 0, 1, 1, and then the number shown is 3. And then next we activate the A4 bar from the decimal input, and then we can see the binary output Y2 lit up, so it's 1, 0, 0, and the number is 4. So move on to A5, and the output is 1, 0, 1, and the number is 5. And then we activate the A6 bar, and we can see the output is 1, 1, 0, and the number displayed is number 6. And then for the last one, we activate A7. And for the last one, all 3 probes lights up. So that means it's 1, 1, 1, and it is showing the number 7 at the 7 segment digital display. Okay, so this is basically how the encoders work. So you receive the decimal input here and then converts it and turn into binary output. And it can be used in many applications, and one of the application is of course this one, the 7 segment digital display. So this concluded my presentation. Thank you.
Hi, my name is Loong, and after I explain about the encoder, so now I will explain about the 2-4 decoder. So, what is a decoder? Okay, so decoder is basically the opposite meaning of encoder. So, the function of decoder is actually converting the binary input into the decimal outputs. So this is a function of the decoder. And what does 2-4 means? 2-4 is actually means by there is 2 input and 4 output. And the input is binary and the output is decimal. So why 2-4 not 2-6, 2-8, 2-10 is because that the decimal output is 2 to the power 2 power to n, and the binary input the binary is n and the decimal is 2 power n. So if the binary have 2, so the decimal output will be 2 power 2, and that's 4. So that's why it's called as a 2-4 decoder. Okay, so you can see here in the multi-sim, this is the circuit, the diagram of the 2-4 decoder. And we can see there's 1A, 1B, this is the binary input, 1Y0 until 1Y3, this is the decimal output. And this pin 1 is the enable input, and this enable input will act like a switch to activate or inactivate the decoder. And we can see at the enable and the decimal output, they have a small bubble here, same like encoder. It means by its active low. So when there is 0 input, it will activate. If input is 1, it will deactivate. Okay, so we see the circuit diagram of the decoder, which is this one. Okay, so this is the circuit diagram of a decoder. As we can see, the decoder is built by 2 inverter and 4 3-pin AND gates. 2 inverter, 4 3-pin AND gates. And we can see there's 3 switches here, A1, A0, and this switch is the enable input. So because you see from this table, okay, when enable is at 0, A1 and A0 is don't care. So that means when the enable input is turned off or there's no input at the enable there, no matter what input you give to A1 and A0, okay, there's nothing will be activated. So we can know from here, we can know we need AND gate to build the decoder. Okay, so the 4 AND gate, the third leg, the third pin is connected to the enable, and then both 4 AND gate, the 3 pins have different combination. Like this first one, the first pin is connected directly to A1, and the second pin is connected directly to A0. And then we see the second AND gate is connected directly to A1, and the second pin is connected after the inverter. So is the inverted A0. So both 4 will have different combination, and so the LED will light up only one. Will only light up one by one in different condition. So now I will simulate it for you to know how it works. Okay, we play the simulation. Okay, you see, when we close the enable input, okay, no matter how you switch on, switch off, giving input, activating, whatever, do to the A1 or A0, there's nothing it will do, because the decoder is inactivated. So we turn on the enable input. Okay, we activate the enable input, and then by following this graph, the first combination is 0 0, so 0 0, and then we can see the Y0 leads up. Okay, Y0 leads up, and then for the binary input 0 1, binary input 0 1 will give decimal output Y1. So Y1 leads up, and then the binary input 1 0, 1 at A1, 0 at A0 will lead up Y2, and that means the decimal output Y2 will be activated. And for the last combination 1 1, okay, both 1 for both binary input, okay, will activate Y3. So that means the decimal output Y3 will be activated. Okay, so this is basically how the decoders work, as concluded. So after this simulation, I have concluded my presentation. Thank you.
Hello, my name is Runieza. So now I'm going to show the simulation for 3-8 decoder circuit. As we know, 3 to 8 decoder circuit has 3 input and 8 output. That is why it is called 3 to 8 decoder circuit. This output that I get was for 3-8 decoder was by using 2 to 4 decoder. As we can see, there are 3 inputs, and one of it was enable line, which is this input, because that is why we put this not get here. Okay, so I will run the simulation. As you can see, the input was 0 0 0, and the D7 will be in active conditions. When the input is 0 0 1, D6 output will be in active conditions. When the input is 0 1 0, the D5 output will be in active conditions. Next is when the input was in 0 1 1, the D4 output will be in active conditions. Next is when the input is 1 0 0, the D3 output will be in active conditions. It is the same when the input was 1 0 1, the D2 output will be in active conditions. Next is when the input was 1 1 0, the D1 output will be in active conditions. And the last one is when all of the input was in high condition, which is 111, the output for D0 will be in active conditions. So that's all for this lab, and thank you.